Hey guys, so I'm back again. Something very interesting I had to share it with you guys. So I have been working a bit over time on this particular project, and what I've done is I have created this spawning system where um you can basically um, define the number of objects that you want to spawn, and then the location is based off this particular box collider that I've created. So you can see that the box collider basically have this box extents or the box dimensions. So what we're going to do is we are when this particular function is called within this BP, of course. So we get a reference to this box object, and what I do is I take the x value, and also I take the x value again for this particular scale, meaning the word location, basically where it's currently located, that x value, and then the dimension of this particular thing, and then we add them together and basically get a random value between the added value and the original value. So what we end up is we get a point, we get an x-axis point um, somewhere in between this particular box, meaning this particular dimension, right? So similarly, we do the same thing with the y and the z, of course. So what if you look at the z is just simply the word location. So I don't add the dimension of z, because if I do that, I may end up basically spawning the object in the ground, meaning within the ground. So that happened to me. So I decided not to do that. So anyway, it doesn't really matter. So we still have some variations going on when we basically spawn these objects, and then based on those values we generate random numbers, of course, and then assign those random numbers to this spawner, or this what do you call it, the spawn vector, and then that spawn vector or spawn locate transform is assigned to this spawn actor function. And then of course the class that I want to be spawned is also a parameter that we define here, actor to spawn, and then the visibility is set to editable in the blueprint editor, or rather on the Unreal editor. So we can assign values to it depending on what we want to spawn. So if you go back, the other thing I have done is basically to be able to generate random colors for every single object that we create. Like for example, if we look at the car value, we can still assign the values that we want for the three colors, the body, the wheels. But now what would happen is that if we don't assign any colors, it's basically going to generate this random colors three times, once for the body and one for the front wheels, and then once for the back wheels. And then of course I have this minimum and the maximum color intensity that I also defined as some float variables, or rather int variables, float variables, yeah. So from, so you can see that minimum is 0, of course. From 0 to all the way to 2 we would get a random number, and then that those values are being passed on to this particular function. So if you look at the function, um, you can see that we get that minimum and maximum value here, but you will see something funny here. um, I'm getting those parameters, those values as floats, and but what I get is I basically generate a random number between the two. It's not the best thing to do, but I would definitely change this parameters of this particular function to be of the type integer, so that we don't have to do this conversion, because I don't want fractions. I want solid colors like 1 2 3. I don't want 1.1 1.2 like that. So I always want solid colors, so that we get very clearly defined colors that we get. So we basically get R, G, and B, three random colors, three random values. So I would do a sum of these three, and if let's say I get a 0, um, then this branch will take me to this particular return value where I hard coded some colors like 1 to 2, 1 and 2 for red and green. So blue I left as black, or rather 0. And if of course we get a proper color out of this random numbers, we would just return those colors as it is. And then the return value, of course, if you look at it, the return code is a linear color. And then if you look at the event graph, so that's what we are getting. We are getting this random color output from this function, and that we set to the variable, and then again that variable is set to the vector parameter of that body material that we already have a reference to. Right, so this is how it is done. The same thing has been implemented in this one. um, meaning in the hovercraft as well. So now what we look at is look at the spawner. So we already seen this thing, but if you look at the event graph, or rather the event graph, we will see that on event begin play, meaning whenever this class is created, or rather this object is created on the scene or the game started, then I have a branch. If all of them have already been spawned, then we don't do anything. But other than that, we have a gate going on, and then we have this spawn function that we have already seen what it does, meaning it's basically spawning those objects in random locations within that box. So and then we also keep track of the number of units that have been spawned, right? So if, let's say, number of units spawned have reached the maximum units that we wanted to spawn, then we basically go back to this gate close, or meaning we don't spawn anymore. And then of course we have this retriggerable delay that will basically go back to the enter again. So as long as all units have not been spawned, this condition will be false, and then this will always go to this retriggerable delay and keep on entering the gate. And then basically we end up spawning objects until um, this particular condition gets false, and then we end up closing the gate, and then and then we exit from this function. There's nothing more to do here. All right. So if we play now, let's see what happens. All right. So you can see right off the bat, those objects are being spawned, like those hovercraft, and then those quads, or rather the cars, and and then you will see the coolest thing happen. You can see those cars flying over. That looks so awesome, man. I really love it. Wow. And then you can see the suspension in work when those cars hit the ground. You can see, you can see those suspension really working hard and making the landing as smooth as possible. But you can see those, meaning they are spawning like crazy, and then most of them are colliding with each other, and they can't really do anything because they don't really know what's ahead of them and what's on the left or right. Oh, you see, look at that guy. Something crazy going on with it. Hmm. All right. So it looks like still some tuning to do. Uh, but anyway, uh, so another thing I would want to do is basically to implement some sort of logic, or some sort of an intelligence that they can look ahead and then see if they are going to collide with something, or some other car or some other hovercraft. Then they should either reduce the speed or turn left and right to avoid. So those collision avoidance is going to be fun, but at the moment they don't really do that, and then they would just spawn those 50 units each and then just fly over. And some of the cars have basically crashed, but they are still going on. So that's what it is. You can just simply let's do one thing crazy. So I'm just going to go ahead and then say maybe 0.5. So these cars are going to be spawned in 0.5 seconds interval, and similarly I'm going to do the same thing for the hovercraft. This is going to get really crazy very fast. You can see they are spawning at a much higher rate now. Oops, there it comes. Awesome. Yeah, okay. Alrighty then. All right. Hope you guys liked it. Then we are gonna get back to work, and then I got a few more things to implement. And yeah, take care, guys. Bye bye.